Thanks, guys. So I'm aware I'm between between the last talk and the grill, so I won't take you that much. Although at the same time, I was said I have no time limit because this is the last talk, so maybe I will keep you a bit more busy. So let us start with the official teaser, so that you don't forget where we are. Don't hesitate to tweet about us. And yeah, I mentioned already the word grill, so let us start with a question. Who of you has toaster at home? Okay, great, yeah, that's quite some few. And how many of you were thinking about building a toaster? Like, why not? No, not really, me neither. But it turns out that there are some crazy people around there on the world who was thinking, hey, why not to build own toaster, and from scratch. So this guy, Mitch Thomas, he actually had an idea, well, let us have a look under the hood what's on the toaster, because it looks actually quite simple, and it turns out that it has about 400 components made out of 100 materials, which makes this thing not easy, but still he decided, okay, let us go around the world and collect the materials, raw materials, and build it and see how it works. And so he spent about 9 months and thousands of dollars on building his own toaster. And yeah, he had to figure out how to produce steel, how to produce plastic, how to produce copper, and believe me, it's not easy to build it from scratch. And the process looked kind of like this, and the experiment has been finished with partial success. The toaster looked like this, and it toasted for about 5 seconds until after it kind of melted down. So keep it in mind. If you are interested, by the way, it's TED Talk. You can have a look on that. My name is Marcin, and I want to talk about toasters. So comparing the spending he made, as I mentioned, some thousands of dollars to the toaster you find in Migros for 15 bucks. It's quite much effort at the same time. So if you have a look on there, it's like available now. And by the way, it can work even a bit longer than 5 seconds, because you get guarantee of 2 years, which is quite impressive. So yeah, we're gonna talk about toaster and running web platform with no servers. Keep it in mind, this toaster story, we will get back to it. So yeah, agenda for today, I want to briefly introduce you to Homegate and the story behind it. Then I want to show you architecture, the new architecture, serverless architecture, examples of services we implemented and are operated already in production, and then we do kind of summary what works and what doesn't. So Homegate, most of you, I guess, know it. You start with search mask, you enter the city you want to live in, some other criteria like price, you get some listings listed, and then you find one which is nice, you contact it with this nice contact form, and if you got luck, and then you got the flat, right? So from user perspective, it's kind of really dumb process, right? You need to enter exactly exactly the city, exactly the number of rooms, all the criteria, and we just list them. We don't assist the user at all, right? And so it was the starting idea 2 years ago to say, well, after 18 years of Homegate serving really nicely and helping people to find their place to live, we need to change a bit and rethink the way how the user find their flat. We actually want to guide them and give them more guidance when looking for a flat. So we want to maybe understand what is your life situation, where you work, do you have kids or no, and then give you some ideas where you could live the best. And so with this idea, marketing wrapped it nicely in something like empowering Switzerland's decision around real estate. It was quite much work to do to get there. And yet, that was the starting core beginning of 2018. Monolithic application in outdated technology, which is kind of, I guess, not new for you guys, because everyone has to do with it. With complex release process, basically, you are not able to iterate fast and deploy it fast in production, right? And only few engineers who spent roughly 70% time on fixing bugs, and then doing release, spending another 30% on this release, and then fixing bugs after this release. So kind of that loop where you actually don't provide new features or value for the user. So we had to we had to change a bit the way how Homegate works. So we wanted obviously to bring the value as soon as possible, right? So the first task was we need to get more engineers on board. in order to make an impact as soon as possible, right? And we need to also make sure that they can work efficiently. And microservice approach seems to be a good fit because you can organize teams around the services and then they can work independently, iterate, release independently, right, without stepping on each other's toes. And then most important, what I already mentioned, is make impact as soon as possible. So make sure that every line you write matters. And this is how we got actually to serverless. So you might have heard different definitions around serverless. I'm going to stick to this one, which is mindset and approach how you actually develop software. Meaning you don't build or own anything which is not core of your business. Meaning you want to save time and make impact, right? And again, what is core of our business is actually helping people to find the best place to live, right? Rather than helping servers to find the new racks or whatever. So with this approach, it seems like the combination of backend as a service and function as a service is really good fit, because for the part which is not specific for your business, you take simply services which are available there, right? And for the part which is specific to your business, you build it on top of function as a service, which is really abstract, because what does it bring is, first of all, you don't have to care about servers, right? So administration, you don't have it. You don't have to patch anything. It's done for you. Then function as a service scales automatically, meaning if you have more requests or you attract more users because your features are so cool, you don't care about it because it scales automatically based on the event number or on request count. Moreover, you don't pay for the idle. So, for example, our platform is not really used during the night, apart from some single users, but this also generates some savings. And what is also important is availability and fault tolerance is built in, meaning the compute power, right? You have it all the time available. You don't care about, having different data centers. It's simply there. If one data center does not work, your workload will be processed by another data center, and it's transparent for you. So basically, you really don't care about this layer, and it's quite much when you think about it. So how the common architecture looks like, you have some event source, like for example, changes in data state or requests, incoming requests, and those triggers function, and then function interacts with other services, right? This is more or less the overview of how it looks like. Now, the question we had 2 years ago is, okay, where do we go actually? Which cloud provider do we choose? And it was also clear for us, we don't want to build any kind of isolation or abstraction layer to make sure that we can migrate from one to another. So it was for us, okay, we need to make a decision and go with it. And we went with AWS, and the reason for that was, first of all, we had prior knowledge already or experience, but moreover, AWS has quite rich offering in terms of serverless services, meaning those which actually no require much operation. So if you look at this graph, there are services which requires quite much operation. So for example, on-premise, right, you need to take care about everything. And you have some here like Lambda, DynamoDB, or which is a database, or S3, where you basically have almost no operation. You just use them, they scale, and that's what I already mentioned, the characteristics, right? And that was the reason. And I mean, another reason was the number of services provided by AWS, which is really impressive, and it grows every time. Not that we use all of them, but it gives you at least a possibility to innovate and consume some of those, which was a good sign. And very often when I mentioned about it, that we went with AWS, many people say, well, but you are then vendor locked in. And I say, yes, it is something which we were aware of when making the decision. And so how we made this decision was, we considered obviously the risk and benefits out of it, right? And so the main argument is, first of all, what if the vendor shut down one of your services you just use, right? And so let's face the fact, AWS has never shut down any service, meaning the very first service, which is a SimpleDB, is still there and still used by many companies. On contrary, for example, to Google. So keep it in mind if you consider going to GCP, make sure that your service will be there in 1 year. Then another concern is what if the vendor has an outage, right? So looking deep into our eyes and hearts, it was clear for us with our budget, we are not able to provide the level of availability as AWS does. So even if there are some outages, those are kind of outliers, and the SLAs are much higher than what we can provide. And yeah, the third one, which is, I guess, the most common one, what if, for example, AWS increases the prices, right? Then we are locked in and we need to pay more. First of all, I guess there are more companies, significantly bigger, who will have this problem. And secondly, again, let's face the facts. So AWS has never increased the prices. Actually, they decreased the prices 67 times over the course of the years. And some of those were half of the price reduction, so which were pretty good signs, and we were confident with doing this kind of vendor locking, which you most probably heard already about quite often. So now, 1.5 years later, we are 50 plus developers, and we have quite some few serverless services in production, generating value for the user, which is, I guess, a great achievement. In terms of technology, so that you have an idea, we are using, as mentioned, AWS, Node.js with TypeScript, serverless framework for deployment, Vue.js in front end, and for monitoring Datadog, for deployment GitLab CI/CD, and if you are interested to see more, go TechRadar Homegate CH, and you will see which technologies we are using, which we evaluated and won't use. So don't hesitate to check it out. Now, I mentioned microservice architecture. That's very, very overview, like from 10,000 feet high, right? But just to get an idea, every microservice is built around the bounded context and has its own data for its part of domain, and replicates also part of the data which is necessary for the business logic. And the interaction with other services happens through two ways. So one is asynchronous, which is this pub/sub channel. In AWS, it's SNS, which is simple notification service, and API gateway, which is RESTful API. Other services subscribe to this pub/sub and consume the messages. We have also an extra SQS, which is kind of meant to be a replay mechanism. In case we have a bug or outage of the service, we are able to replay the messages from the last 14 days, which gives us kind of good confidence if there is a bug or an outage. So this is how it looks like. And one thing I want to mention is you might have already heard about the concept of accounts in AWS. So basically, this is where you log into AWS. And there are different approaches towards it, and it was one of the very first questions we need to answer. And I guess for many companies, this is difficult to decide. So we went with multi-account setup, and we can really recommend it. What does it mean? Every microservice it has two accounts. One is for test stage, one is from production. And we have also some special accounts like billing or provisioning, where actually automatically new accounts are rolled out when it's needed, plus some extra accounts like, for example, shared services for CI/CD pipeline. Why I recommend it, and we make a really good experience with it, because first of all, the services can consume the throughputs isolated, so you have no impact on each other in terms of services, right? As you know, every service has some limits or some throughputs defined, so you don't run into this risk of I need to consider what other services are already using. You simply know, okay, I am in an account which is clear, kind of. And also it reduces blast radius, meaning if your service goes wild and you have some bug which consumes all of your quota, you don't kind of care, because this service is isolated and does not affect your other services. So you don't want, for example, that error in logging makes your production down, right? Which could happen with one account. And security, which is also very important, so that you, for one account, you can really define what services the user is allowed to use in this account. So you don't run into risk that someone all of a sudden started a Redshift cluster, which is kind of very expensive. And in our case, we know we are using only functions, so there is no need even for starting any instance, right? Or maybe for some specific accounts. You can really control it quite well. And demarcation of cost, meaning you know exactly how much each service costs you in production. And you might have heard about the term FinDev, which means basically you can calculate how much the feature costs you per user, and that's possible actually, because you can calculate the cost down to the particular request, and with having these separate accounts, you really know exactly how much do I pay for a given feature or given service. So yeah, that's an example so that you have an idea how the function looks like. So basically you have a handle method with an event, right? and in this case it's API gateway, which is REST request. You have access to the body of the request, and then you trigger as you would do it with Node.js application service and implement the logic there, and obviously you respond with the status code. So it does not really differ from this perspective to what you most probably know with Node.js or other programming languages. So let us have a look on an example of the service. In this case, it's listing importer service. What does it do is it ingests the listings or publish the listings online. So basically, we are working with Realtor agents, right? And they publish the listings on our platform. Also, private users can do it. And the listing importer service is responsible for validation of those listings and making sure that they goes online. So this is how it looks like. The agent presses the publish button, it hits our API gateway, and those two rectangles are actually lambdas. First is the validation, which happens synchronously. Once we say, okay, it looks good, we send the response to an agent, and then the lambda triggers asynchronously step functions. And about step functions, I will talk in a while. So the listing goes processed, enriched, and then we publish it to this pub/sub channel, which I show you already before, so that other services interested in it can consume it, and I will show you also an example of it. So what is step functions, you might ask yourself. Step function is actually a service which helps you coordinate different lambdas or different functions, and has some really neat features. So let us have a look on what listing importer step functions looks like. So first of all, you can trigger with step functions some functions in parallel and then wait until all of them are done, and then you aggregate result. So if you have a look on those parallel steps, you see we are, for example, uploading images, doing geocoding, and possibly translate the listing in different languages. And you see here this retry arrow. This is something which step functions brings in. For example, if your lambda throws an exception, you can define how often you want to retry. You can define also the strategy, how you want to retry in time. So for example, after 2 seconds and after 4 seconds and 8 seconds, or different strategies for retrial. You can also implement branching, and you can also implement waiting, meaning you don't pay for the time when you wait for other services. In this case, for example, we have still part running on-premise legacy, and when the step function is writing those search index to legacy, after that it waits for confirmation. Yeah, it's already indexed, and now you can publish an event. It's online. So basically, step functions is something which again coordinates the lambdas and gives you some goodies like branching or retry mechanism, which again helps you keep the implementation of your service clean, because those aspects which are more of infrastructure or error handling are extracted out of code, which is really nice and helps you keep the code clean. So yeah, now you might wonder who actually consumed those events. So you might know that on our platform we have also subscription, so you can basically save the search and then you got notification. And I will show you also how this service looks like, just to an overview. So this is the listing importer we talked about, and then the message got published and it's consumed by the Lambda, which is called check matches. And then in Elasticsearch, we store the queries of the user. So for example, price between 2,000 and 2,000. This is what our user is interested in, right? Now the listing comes in here, and the Lambda do reverse query. It's called percolate in Elasticsearch. And we see, okay, for some of those subscription, this listing matches. Now, what is really specific about this architecture is we use queues. And in fact, we create queue for every subscription, which is kind of, with AWS you can do it. When you are on premise, most probably you cannot afford doing thousands or hundreds of queues. And yeah, once we see, okay, this listing matches for given criteria, we put it to SQS, and then we have the part of step functions, where basically user can define how often I want to be notified about the listings. And with this wait step, you can really be fine-grained whatever you like, from 1 minute to 1 year. This is what is supported by step functions, and then we fetch basically the listings from the queue and send the email out. So that are two services I wanted to show you, so that you have an idea how the serverless implementation using Lambda looks like. Many people keep asking, okay, what about local development? How do you handle it? How you can actually debug the code, right? And yeah, at the very beginning, we were also kind of very focused on how do we get these things running locally, and there are many frameworks which kind of emulate the environment. And after some time, we gave up. Why? Because it turned out that we that we spend more time debugging what's the issue, why it does not run locally, rather than finding the real issues. So if you are tempted to do it, don't do it. If you are in cloud and especially consuming this number of services, so forget about local development because it's really it's not comprehensive and it's brittle. Simply write more tests, more unit tests, especially to shorten the feedback loop, so that when you deploy, you know already, okay, it should kind of work. And then those integration tests, deploy them to environment, to real environment, because these tests tell you a true actually, right? Emulation does not necessarily tell you, okay, does it work or not, right? And at the end, what is really our experience is with having a test running in the cloud, you kind of need to be sure that you are able to reason why the test was failing, which helps to increase the observability of your systems, right? Because once you have a problem in production, it might be that the problem is similar to what you had before in your test. So it's easier to kind of pin down the problems when you train it before actually production, right? So that's the idea, and how do we do it? So I already mentioned about accounts. Basically, so master obviously is deployed to the test stage, but we have also separate stacks. So it's like a fully fledged service deployed separately for every single branch, so that integration test can run again the branch before getting merged. And also every developer can spin up its own microservice in the test account and interact with it and test it. And it's fully automated, so every branch, when it's created, it deploys a new kind of microservice replication, and you can interact with it, run the test, and whatever needed. So, yeah. So summary. Yeah, it's really a steep learning curve when you go to cloud, and especially when you go with something which is as such cutting edge as serverless is, especially 2 years ago. It was a quite big challenge for us to find people with experience, or actually, to be honest, we didn't find them. So we found out those people are not existent, or maybe in low quantity. So we need to kind of learn by doing, and the community was also kind of small. So if you know this phase, if you Google something and you don't find the results, that was very often our experience, yeah. And yeah, there are in fact a lack of established patterns and good practices. So you need to rethink some things which are kind of were already solved, right? But we are actually engineers good at it, and we enjoy it, right? Finding new patterns again and again, and not much tooling, or there is a tooling, but you actually don't know what will stay there on the market, because there are many startups trying to solve the problems you have, but you don't know what will be there in 1 or 2 years. But to be honest, it changes. So after those almost 2 years or 1.5, it looks like the patterns are emerging, the tools are better and better. So the whole ecosystem is getting more and more mature. And from a positive side is like really we are able now, with this experience we already have, we are able to bring new features faster. And what is really great about it is once you deploy to production, as I already mentioned, you don't care, because your server are patched, it scales if you have more users, and it's fault tolerant. So the operational part is actually much less comparing to what you would have without going with this approach. And yeah, as already shown, number of services, we are leveraging some of those, and again and again discovering the new possibilities. We will delight the people in the future. So yeah, that's it, more or less. Ah, wait, what about toaster, right? You might think now. So yeah, remember the toaster looks really simple, right? And this is our perception as an engineer always. The problems look simple and we could just implement it within 1 day, right? Why we won't do it? Why we are looking for yet another service, and we need to pay for it, and we could do it with our resources, right? And yet, as you saw also, underneath it's a bit more complexity than you would think, right? So if you would ask me what I want you to remember from this talk is, don't build your own toaster, because the complexity as the same as a toaster, the same for software, is much higher than we tend to see, right? So why should we build now another data center and deal with this complexity of data center? Why we should actually run new Kubernetes cluster and keep some people busy in our company keeping it up and running, right? Why we should actually bother ourselves with complex auto-scaling configuration, and for those who did it, you know how complex it might get, right? So rather than that, have a look what is out there, also think about the serverless approach, check out a function as a service, and use it and focus on what really matters for your business and for your users. With that being said, that's it. Thank you. I hope you enjoyed the talk. And I rushed a bit through the slides, so if you have any questions, don't hesitate. Still 5 minutes. Yeah, go on.
I have a question. So the serverless runs on the premise that the infrastructure is going to sort out these problems like scalability and deployment and whatnot. Do you actually test that? So did you try to crush this serverless architecture on Amazon and see how well it actually bends underneath?
I think what is quite easy to crush is the on-premise application, because if everything scales in AWS and it scales, you basically run into problem. You might have heard about denial of wallet, meaning you spend a hell of money, right, without having any limits. And whether we could crush AWS, no, we couldn't, because there are obviously some limits on everything you are using. If that was your question.
No, I was more interested in stress testing your application deployed into this infrastructure, because obviously if you deploy on your own infrastructure, there is a limited physical limit, right? Here, yeah, so at AWS there are two limits. One is the native AWS limits, and another is your wallet, right? And you need to make sure, really, especially when having an application on the cloud and on-premise, that you don't crash your downstream system on-premise, right? Because this one does not scale. So there must be some back pressure mechanism to make sure it can keep up the pace you have on your cloud, right?
I see that for communication between services you're using SQS plus SNS. And as far as I know, they don't provide like Kafka exactly once delivery.
Exactly.
At least once. You're dealing that on your side, on every service you're doing the duplication.
Great question. Yeah, thanks for that. Yeah, so you have with SNS, you have the at least once delivery, right, and no order delivery. And yes, every consumer has to deal with that. Yeah.
Is that a problem?
Yeah, that's additional complexity for sure. For services which store those events anyway, is not the problem. But for some which wouldn't care maybe about it, they have to have a kind of store to make sure that you do the duplication, you do ordering. So it's more complexity, definitely. But the advantage is with SNS and SQS that it scales again automatically. On contrary to for example, Kafka or even Kinesis, right? When you have shards and you need to make sure that you have enough shards for the throughput, that's again something you need to think about. Yeah.
Yeah, Marcin, you know that I'm more a fan of serverless because you get rid of all the patching shit.
Yeah, exactly. So security is higher. Yeah.
Yeah. So I have a lot of discussions with companies of Tamedia, but also other companies that say that with serverless you get rid of that problem, you scale good, but it gets more expensive. But they have no experience with that. So as you are already in the serverless area, did you encounter that going to serverless scales better, but the expenses are going much more up, like scaling, or is it just an urban legend?
Great question. In terms of cost, as I mentioned, first of all, you need to be careful about how you use your services and put some limits on it, right? If you don't put them and all of a sudden you have, many requests you don't want to have, it scales and you pay for it. But in terms of services, everything is healthy. Honestly, our bill, AWS bill, only 1% is the execution time of Lambda. The rest are other services. So I don't think that's true. 1% of our bill is Lambda execution time. So it costs us actually nothing compared to other services like storage or S3 or Elasticsearch or whatever we are using there.
Okay.
Yeah.
Thanks.
That's actually quite interesting fact, yeah, to know it. Cool. The very last question before.
What was the biggest unexpected surprise you encountered when
Honestly, I mentioned it. We were trying and we were very, very desperate to get experienced people on board. I don't know whether I'm allowed to say it or not, but we requested from AWS multiple times, bring us guys who have an experience in serverless, and it wasn't possible simply. So that was the kind of biggest surprise. You would think there are some people out there having an experience. Many of them pretend they have it, but you know, I built my own toaster at home and it ran for 5 seconds, but it's not what you want to offer your users, right? Yeah. So yeah, cool, great. So thanks a lot for your time. I really appreciate it.